All right, I'm assuming everyone has questions in the homework, right? Okay, so that's why I have this up there already. So this is for the first two homework questions. Have you guys tried the homework yet? Okay. All right, so you guys know the general setup, but for those who haven't started yet, you have a triangle that looks like this, although I labeled. So the picture on the homework doesn't quite look like this. I put some extra labels on it. But you're given the height of this triangle, but it's not, the whole triangle isn't a right triangle because it's not, one of the angles is a 90. Anyhow, so you have this angle theta, this angle phi. So phi is given, right, in the problem. You know what phi is. So I'll circle the things that are given, for instance, so you know. So the things in green are given. So you're given that initially. You're given the height of the triangle, this, and you're given this, which I called C in the original picture. But I call it C1 here because there are two C's. So C being the hypotenuse. There's a hypotenuse of one triangle and the hypotenuse of the other triangle. But what was given was just this hypotenuse, the one on the right, h, and the angle over here. You weren't given this angle or anything else related to the triangle. So b1, b2, c2, theta, they're not given. Right? So for one problem, the first one, you had to figure out the area of the original triangle, this one, and then you did something to theta, which I'll explain after we figure out how to do the first part, and then determine the new area of the newer triangle, and then find the difference between them. That's the first one. The second one is a similar one, except it's related to perimeter of the triangle. All right, so let's focus on the first one, right? So, which is the area, right? Number one is what I'm trying to say. Okay, so to find, if you read the question, the area of any triangle, including right triangles, is 1/2 the base times the height. So the height, they just need to open the door. Okay, so the height is given in the original problem, so you don't need to find the height. To find the area of the original triangle, you basically just have to find the base. But neither of the bases are given. In other words, B1, I said, is the base of triangle 1, the one on the right-hand side. So, by the way, these form two right triangles, right? If you draw the height here, these are two right triangles. So you have a right triangle on the right-hand side, and then B1's the base of the triangle on the right-hand side. Then you have a triangle, right triangle, I should say, on the left-hand side. And B2 would be the base of the triangle on the left. So it boils down to, at least the first part of the first problem, to figuring out what is B1 and B2. So if you look at, let's do B1 first, right? So if you look at the right-hand side, right, what are you given related to the triangle on the right-hand side?
You would give the hypotenuse and the height.
All right, so you know two of the three sides. So what's the easiest way? There's more than one way to do it, by the way. People came to me for office hours yesterday, and I saw all sorts of ways to do this. But one way to do it, what's the easiest way to do it if you know two of the three sides? Pythagorean theorem, right? So basically, I'm not going to write everything I say down. I mean, the video is going to be uploaded, so if you want to, I'll write little things down, but not every single thing down. You watch the video. For people who's not here, watch the video. But basically, you can just use the Pythagorean theorem, right, to find the unknown side, B1, correct? Does everyone know what I'm saying, right? Like C1 squared is equal to h squared plus B1 squared, so then you solve for B1. So that gives you B1, right? Now, let's look at B2, which is the triangle on the left-hand side, and we're trying to find the base of that triangle. So what are we given for the triangle on the left? Remember, they share the same side h, right? That's a key thing to remember. But, okay, so knowing that, what are you given regarding the triangle on the left? You're given the angle, and you're given h, which in relation to phi is what? Is it the hypotenuse? Is it the Adjacent side is is the opposite side. So it's the opposite side, right? So you're given the opposite side of the angle. With respect to phi, you're given the opposite side on the left-hand side. And you're trying to find B2, which is what in relation to phi? The adjacent side, right? This is like what we did in class, right? So you're given the opposite, you're trying to find the adjacent. So what do you think you use? Tangent. All right, write that down quick, because this is trig. So just emphasize the importance of trig here. So what would the tangent of phi be if we're doing it? If I write down the tangent of phi, what exactly would it be according to the labels here? It's the opposite side, right? H, right? Over B2, right? This is H. Looks like a B. That's H. Okay, so you know H, you know phi. So you just, find tangent B2, right? By solving that equation, right? So you do a couple steps of algebra and you can find B2. Okay, so then you know B1, you know B2. So then what is the entire base? If you know B1 and B2. You're trying to find the base of the entire triangle from here, to here, right? So yeah, you just add them up, right? And that's the total, that's the entire base, right? That's the base of the whole thing. And then that's one part. I mean, that's almost one part. Then you just have to find the area, and the area is given, in the problem itself. This isn't, it's 1/2 base times the height. The height you're given, the base you just found. So you just, put that in your calculator, and that gives you the original area. All right, so does that make sense? So you're using trigonometry and geometry to do the first part. Okay, so then what happens is this. So I'm going to borrow this to show you what happens in the next part, because it's good to see graphically what happens. All right, let me get rid of this though. All right. Okay, so what you're doing in the second part is you're basically changing theta. You're making it smaller. So when you change theta, what happens is so if you make theta smaller, the whole triangle basically the height gets reduced, right? But the bases don't change, right? The base of the triangle is still the same thing. So the B1 and B2 that you found in the first part, you can use for the second part because it doesn't change, right? However, everything else changed. In other words, phi change is no longer what it originally was because the whole triangle got smaller. Theta changed, so I call it theta prime. H changed because it got smaller. C1 changed because that's supposed to be lowercase c. You get the idea. And I'm not going to change it because it changes everything, but you get the idea, right? So everything else changes except B1 and B2. You don't know anything else. You don't know anything else but B1 and B2 right now. However, you can figure out what the new theta is because I tell you what the theta changes by. However, we have to do one more step from the first part. We never knew what the original theta was. All we knew what phi was. That's the only thing we knew. From the original triangle, that is. So what we first need to do is actually find what theta is in the original triangle so we know what it is in the second triangle. So the question is this. In relation to theta, on the right-hand side, right, just looking at the right triangle, we know all three sides. So technically, you could do it many different ways. But just using the initial given information, right, which is H and C1, how does H and C1 relate to theta? In other words, what is H in relation to theta? It's the opposite side. What is C1 in relation to theta? It's the hypotenuse, right? So if we know the hypotenuse, the hypotenuse on the opposite side, what trig function do we use? We use sine, right? So I'm going to squeeze it in over here. The sine of theta would be exactly equal to what, according to the labels I have here?
H over C.
Right, H over C or H over C1, or however you want to say it, in the original sketch at C, but here it's C1. Wow, it's a full house. This never happens. Okay, so anyhow, you know h and C1, so you want to find theta. So how do you find theta if you know? So you know h and C1. So basically, you know the right-hand side is just some decimal. Right? You divide h by C1, you get a decimal. So the question is, how do you find the theta? Not the sine of. You have to take the inverse sine, right? Just like we took the inverse tangent in class, you do inverse sine, and that gives you the original theta, right? So now you know theta, the original theta. And depending on your particular problem, because it's slightly different for everyone, the theta in the second triangle is the first theta reduced by some factor. It's like 2 or 3 or 4 or whatever. So now you know what theta prime is, because you take you know, the original theta and you divide it by, you know, x, what, you know, 2, 3, 4, 5, whatever your factor is, right? So that gives you the original theta. So now what you know is this. I'm going to circle what you know in the second triangle. Now you know theta prime when you do that, right? You know B1 and you know B2. That's it, right? Because everything else changed. You didn't know anything else off the top of your head. But remember, all you're trying to do is find the area. So what is the area? Well, the area is this, right? But for the second triangle, what happens is the area is 1/2. But does the base change for the second triangle? No, it's the same base as before. So all you have to do is really find the new height. That's what you're trying to do, right? So if you look at it, well, what triangle do you do more of? For the second triangle, what triangle do you know more things about? The triangle on the right or the triangle on the left? The right. So let's look at the triangle on the right. So in the triangle on the right, remember, all we're trying to do is find h prime somehow. It doesn't matter how. So we know theta prime and we know b1, right? So, and we're trying to find h prime. So in relation to theta prime, the new theta, what is b1? Adjacent. What is h prime? Opposite. So what can you use to find theta prime? Sorry, h prime. I keep on saying wrong things, but you know what I'm saying. Trying to find h prime. So what is the tangent of theta prime exactly equal to, according to this triangle on the right? Whatever. It's h prime over b1. Once again, this looks like a b. It's an h. So h prime over b1. Okay, so then you can find h prime, right? Because you know theta prime and you know b1 in the first part. So then you find h prime, and that's it. You plug it in to this area, and then you subtract the two areas, right? That's a much bigger. The first triangle is area-wise compared to the second triangle. Does that make sense? Anyone have any questions on it? No? All right, the second one, if no one has any questions, go on to the second one. The second one is kind of similar. You do some of the same steps that you do in the first one for the second one, but it's a little bit different. Oh.
So earlier you mentioned inverse sine.
All right.
I was writing something down, so I didn't catch what you were referencing. Were you referencing taking finding theta on the original triangle?
Yeah, you do inverse sine, right? To find the original theta.
Okay. Yeah. Okay.
Okay. Yeah. Yep. All right. Any other questions? All right. So number 2 is the same setup. You know, it looks the same as number 1, except you're asking a different question. So just like in number 1, you're given the same thing. You know phi. You know this one, which I call C1, and you know h. So that's the original given information. However, for this one, you're trying to find the perimeter of the triangle, how long the perimeter is. So essentially what you're doing is finding all sides but h. H doesn't factor into the perimeter. Well, it factors in that you needed to calculate some things. But in the actual calculation of the perimeter, you don't need h. You need all the other sides of the triangle. So the perimeter of the triangle is basically C2 plus C1 plus B1 plus B2. So basically, it boils down to finding all the other sides, right? C2, B1, and B2. So you find B1 and B2 exactly the same way you did as number 1. Exactly the same way, right? If you follow number 1, then you know how to find B1 and B2, right? Everyone, do we need to go over that again? No. So, okay, so I'll go over it quick. So you know C and H for the triangle on the right, right? So what do you use to find B1 for the triangle on the right? Pythagorean theorem, right? That's the easiest way to do it. For the triangle on the left, you know phi and H, and you're trying to find B2, say. So what do you use for the triangle on the left again to find B2? Well, I mean, that's one way to do it, but you have to figure out C2. So if you know the opposite side and the adjacent side, you got to use tangent, right? Tangent again to figure out B2, right? So you use tangent on the left-hand side to figure out B2, and you use Pythagorean theorem on the right-hand side to figure out B1, just like you did for number 1. But in addition to B2, you also need to find C2. So once you have B2, you could use the Pythagorean theorem if you wanted to. Let's just do it with the given information, right? Suppose all you know is H and phi, right? And you want to find C2. It's the best way to do it, right? It's the original given. Because if you have B2 wrong, then you're going to get C2 wrong, right? If you use B2. So let's do it just using H and phi, right? So H is what in relation to phi? Opposite again. And C2 is what? Hypotenuse. So if you know the opposite and hypotenuse, or you're trying to find the hypotenuse, what do you use, right? You use sine, right? So that's something new. Oops, sorry. So the sine of phi is what exactly for the left-hand side? Yeah. That looks better. So H over C2. So you don't know C2, so you solve for C2. Of course, if you found B2, you could use the Pythagorean theorem. If you're pretty sure the B2 is right, you could just use the Pythagorean theorem to find C2. Either way, you get the same answer, right? You should get the same answer for C2. All right, that's it for the first part, because now you know C1, you know C2. Well, C1 is given. You know C2, you know B1 and B2. So then the perimeter is just the sum of those things, right? That's the perimeter. The length of the outside of the triangle is C1 plus C2 plus B1 plus B2, right? You just add those things up, and that's the original perimeter of the triangle. What should we also do, though, before we go on to the next part, that we did in number 1, right? Yeah, we need to find theta again. So you find theta the same way that you did in the first part, right? Exactly the same way, right? Because we need it again for the second part, right? So we need theta. So you do the same thing that you did in the first part, right? Everyone, yeah.
So you're finding theta. We don't necessarily need it though for this, right? But it's just something you do every problem.
No. For this one, it depends on the problem. But for this one, the reason why you need theta is because for the second part, you know how theta changes.
Yeah.
It's given how theta changes. So you need to find what the original theta is so you can figure out what the next theta is, right? That's why. Okay. So you need to do that again, right? Just like you did it for number 1. All right, everyone got that? So then the triangle changes to this again, right? It's the same thing as number 1, right? You reduce theta, which changes the triangle to something like this. Again. So let's go. And so you have to find the new perimeter again. So you have to find the new C2 and the new C1. B1 and B2 are the same thing as part 1, right? As the first part, right? The original triangle, just like number 1. So these B1 and B2 are the same things, but you don't know C1 or C2, the new C1. You don't know H either, correct? But you do know the new theta, because if you take the original theta and divide it by the factor, now you know the new theta. So these are the things that you know about the second triangle right off the bat. B1, B2, and theta prime. But the point is you need to find the new C1. So how would you find the new C1? Let's just focus on that first, C1 prime on the right-hand side. So what do you know? Well, you definitely know theta prime on the right-hand side. You also know B1, and you're trying to find C1 prime. So what is B1 in relation to theta prime?
Adjacent.
Adjacent, correct? Everyone gets that it's adjacent? I'm going through these adjacent and opposite things quickly, but everyone understands what's adjacent and opposite. So this is adjacent to theta prime, so that's that. And then C1 is what in relation to theta prime, the hypotenuse. So if we know the adjacent side, we're trying to find the hypotenuse. What do we use? We use cosine, right? So the cosine of the new angle, theta prime, is what exactly? What do I write down?
B1.
Right. C1 technically prime, but you get the idea, the new C. So you can use that to find C1 prime because you know B1 and theta prime. The only thing you don't know is C1 prime. So now you know C1 prime. Right? Everyone understands that? The only thing we have to find now is C2 prime. That's the only thing left to find. Okay, let's look at the second triangle. What do we know immediately about the second triangle? All we know is B2. That's it. We don't know phi prime, we don't know H prime, we don't know C2 prime. So can you find C2 prime if the only thing you know is B2? Is there any way to find what C2 is if the only thing that you know right off the bat is B2? No, there's no way you can do that. You need to find something else, right? Does everyone understand? If you only have one side of a triangle, that's the only thing you have. You cannot find anything else related to the triangle. You need at least one more side or an angle, right? So does anyone have an idea how we can find another side? All right, we can, H prime shares a side with the triangle on the right. So we can use the triangle on the right to find H, the new H, and then use that for the triangle on the left, right? We needed something else about the triangle on the left. So once again, there's more than one way to find it because now we know C1 prime too. But given the original information here, right? Phi prime and B1. Does anyone know how we can find H prime if you just focus on the right-hand side? Well, okay, so there's more than one way to do it. But just using theta prime and B1, right? How do we find H prime? Tangent, right? Because the tangent, what would the tangent of theta prime be?
Oh, H prime over B1.
Right. Once again, there's other ways to do it. You know, there's more than one way to get the same answer, but that's the best way to do it because it just involves the things that you definitely know. So now you know H prime, right? Because, you know, if you just look at the right-hand side, now you know H prime, but H prime shares a side with the left-hand side, right? So now you know what H prime is, correct? And we know B2 because it's the same thing as it was for the first part. So how do you, what's the easiest way to find C2 prime if you know B2, right? You just use the Pythagorean theorem again because you know 2 out of 3 sides. So now you know C2 prime, right? Using the Pythagorean theorem. And that's almost it. So once you find C1 prime and C2 prime, the new C's basically, you can find a new perimeter. It's just that, right? B1 and B2 don't change from the first part. And then you just subtract the 2 perimeters, and that tells you how much bigger the first triangle is in perimeter compared to the second triangle in perimeter. All right, so does that make sense? Those are the 2 longest of the problems. The rest of them are shorter. But does that make sense? You do those problems? So they're good practice in using all the trig functions, basically, and also the Pythagorean theorem a couple times. Okay, so does anyone have any questions on that one, number 2? Okay, so let's go on to number 3. Number 3, hold on, here we go. All right, number 3 was the proportion problem with the gold thing. So what's written here is actually true. This is how, if something's made of pure gold, it works like this. Anyway, so you have a cube that's made of pure gold. So if you have a cube, the price of a cube of gold is given to you in the problem. So it's CL cubed. It's proportional to the volume, and the volume of a cube is L cubed, right? The length times length times length. So, so C has something to do with the price of gold, but it doesn't really matter, right? It's just a proportion for this problem. That's the beauty of proportions. You don't really need to know exactly what's going on to figure things out. So you're given an initial price of a gold cube. It's something. It changes, depending on the problem. And then you, let's just focus on the cube first. It's a cylinder, but let's just focus on the cube. And you, hold on, I gotta figure out. You increase the length of the side by some factor of the cube. So let's figure out what's going on for that, right? So if you make the length of the side bigger, what happens to the price? Does it get bigger or smaller? Bigger, right? Because it's proportional. Well, proportional to the cube, which we'll get to in a second. But anyhow, the point is if L gets bigger, P gets bigger, which makes sense. I mean, if a bigger gold thing, it's going to cost more than a smaller gold thing, right? Okay, so, but how much does it increase by? So it's not just the factor, right? It's L cubed, right?
Yeah.
So it's so the factor, it's not going to be this high. The factors are kind of small. But suppose the factor went up by 10, right? You increase the length of the side by 10. What would happen to the price of the gold cube?
100,000.
It would go up by 10 cubed, right? It's the factor cubed, right? So you take the factor, you cube it. I mean, you should really know how to do this on your own, right, for the test. But you take the factor and you cube it, and then you multiply it by the original price. That gives you the new price of the gold cube, right? All right, so does that make sense? So you do that, you write down what the new price of the cube is, right? Okay. So then there's a gold cylinder. So the price of a gold cylinder is proportional to the radius squared if the height is the same. So a cylinder has a radius and a height. If you keep the height the same, just make the radius bigger. It's proportional to the basically area cross-sectional area. But anyhow, r squared, right? Let's just focus on that. Okay, so for the cylinder, you got to decrease it by some factor. Decrease the radius by some factor. So if you decrease the radius, what happens to the price? Does it increase or decrease? Decrease. Once again, you're making it smaller, so obviously it's probably going to decrease in price, right? But how much does it change by? Is it just the factor or what? Factor squared, right? So you got to take the factor squared and then take the price, the original price of the cylinder, which is the same price for both of them, the gold and the cube and the cylinder originally have the same price. And then you take the price and you divide it by the factor squared, right? That gives you the new price of the cylinder, correct? So that, you do that, you write that down, the new price of the cylinder, and then all you do is just subtract those two things, and that tells you how much more the gold cube is compared to the cylinder when you change the size of each one of them, right? That's it. It's not that bad, right? All right, so does that make sense?
I'm a little like on this part.
So
Which
for-
part?
So for the cost of the second one, it's just C equals R2 times P.
Come again? Sorry.
If you're solving for C because you're trying to find a cost.
No, you're not solving for C.
Oh,
C is just a constant. P is the price. C is just a number. It doesn't matter what it is.
So just multiplying.
This is related to pi and the cost of gold. It doesn't matter. You don't need to know what it is, right?
Okay.
You're just doing proportions. Yeah.
I'm sorry, could you divide the factor that you squared by the price? For a second.
Other way around.
Divide the price by the factor.
Mm-hmm.
If you decrease r by a factor of 2, is that similar to dividing r by 2 or multiplying by negative 2?
No. It's you're taking r and dividing it by 2.
Okay.
Mm-hmm. Any other questions?
So then you would also divide P by 4, right?
Mm-hmm.
Okay.
Any other questions? Okay. No other questions, right? Okay, question 4, though it says number 5 in the text, that doesn't really matter. The next question is another proportion. It's a multiple choice. You actually don't have, I'm not going to give you that many multiple choice questions on homeworks because you have multiple attempts, so it's kind of trivial on the first attempt if you get it wrong. Then you know what the right answer is for the second attempt, so no one should get them wrong after the first attempt. But still, it's a good exercise. And the only real way, I mean, I could make it so it's like the other questions, but it'd be sort of too hard to make it like that. So it's a multiple choice question. Anyhow, the point is, you're given this equation here. In case you can't read my writing, it's cy to the 4th over x squared. That's what it's supposed to read, in case you can't read it. And you know, what's given is you increase y by a factor of 4. Let me do a slightly different problem, because instead of doing the exact problem that's there, right? Because you can just figure it out. I mean, you get it wrong on the first attempt, you can figure out the second attempt. Let's do a slightly different case. So in the question, y increases by a factor of 4, right? That's the question. But let's change a little bit. Suppose y increased by a factor of 2 instead of 4, right? So we're doing a slightly different question. So you could see another example of something similar. Okay, so once again, I'm changing the question up a bit. If you want to see the full explanation to this one, I'll post it in the homework solution, right? But suppose y increased by 2 instead of 4. What would happen to z if y increased by a factor of 2?
Decrease.
No, wait. Y increases by 2, right? So what happens to z if y increases? It would increase, first of all, right? So how much would it go up by? 2 to the 4, right? I mean, it's proportional to the 4th part, right? Okay, so 2 to the 4 is 16. So z would go up by 16 if y increased by 2. It doesn't increase by 2 in the homework, but it's a similar thing, right? Similar. Okay, so the question is, what would x need to do such that you keep z the same after you change y? So how is z and x related to one another, first of all, or x squared? Are they proportional or inversely proportional? Inversely proportional. If you make x smaller, z gets bigger. If you make x bigger, z gets smaller. So if y makes z go up by 16, we need to change x so that whatever we do to x, it makes z go down by 16, right? Because if one goes up by 16, one makes z goes up by 16, and the other makes z go down by 16. Then they cancel out, and z is the same, right? It's essentially multiplying by 16 over 16, which is 1. So, okay, so what we have to do is change x such that z goes down by 16, because y makes z go up by 16 for this example, correct? Is everyone with me so far? So how do we have to change x? Do we have to increase x or decrease x if we want z to go down by 16? You have to increase x, right? That's the first step, not a decrease, right? You have to figure out increase or decrease. So we want to increase x by something such that that thing squared, because it's proportional to x squared, right, is equal to what? 16, right? We want the factor squared to be equal to 16. So what squared is equal to 16? 4, right? The upshot is if you increase x by 4, that decreases z by 4 squared, which is 16, right? Which would cancel out the increase from y. So that's how you do that, right? And you do this similar thing for the homework, right? Except there's a different factor, right? Does that make sense? Everyone get that? Okay. No questions, right? All right, let's go on to 5. 5 is a conversion with units I made up from nowhere. So I do it for the quiz and the home test too. So you have to know how to do these things. You can't Google the conversion. That's the whole point, right? Okay, so there's this thing, Plick and Lac. I don't know where I came up with it. It's a Plick and Lac, whatever you want to call it. And you're converting some amount of kiloplex per hour to kiloplicks per hour to lacs per second. So it's pretty similar to the example in class because we converted from something, what was it, kilometers per hour to, what do we do? I forget. Miles per hour to meters per second or something, right? So it's pretty similar to that, except it's slightly different. It's similar but different. Okay, so it's going to be a little bit hard to do in general. But for everyone it's different. That's why it's a little bit hard to write down in general. But you have this general relationship between these two weird units, Plicks and lacs. So these numbers are different. So I'm just writing them down as variable. Oops, what am I doing? So it's like, like 5 Plicks is equal to 10 lacs, or, 4 Plicks is equal to 20 lacs, whatever. It changes depending on the question. Anyhow, what you want to do is you want to come up with you can do this however you want to do it. So some people do their unit conversions in, some way. As long as you know how to get the right answer, it's fine. But this is how I do it, right? According to, how I did in the notes, how I did in the PowerPoint. So what I do is I come up with 2 versions of one. So it's a systematic way of doing this unit conversion from this basic relationship between Plicks and Plaques. So, what I would do when I do it, like I said, you can do whatever way you want to do it. If this way doesn't make any sense to you, see some other way of doing it, that's fine. But I convert it to 2 different forms. All right, so, this thing just, all right, sorry, I'm leaning on this thing too much. So if I divide by x Plicks, whatever the number is, it's different for everyone. That's one form of one. Or I can take the inverse of both sides, and I get x Plicks y lacs. So that's just 2 different forms of one from the basic relationship between the 2 units I made it. And then there's a kiloplac in there, so you get a kiloplick. Sorry, you got to convert kiloplicks to Plicks, but that's more or less straightforward. But you could do it if you wanted to. So, for instance, I'm going to say kiloplick is 1,000. I guess I'll write it kiloplick. Sorry, kiloplick. Because kilo is 1,000, right? For no matter what unit's in front of. So you can get a basic version of one from that by dividing by a kiloplick on both sides, or you can take the inverse of that, and you have 1 kiloplick is 1,000 Plicks. So that's a basic unit conversion between kiloplicks and Plicks. And then you have to convert to hours and seconds because the original time unit is hours, the final one's in seconds. But that's just like the notes, actually. I'm going to copy it from one of the, where is it? Oh, yeah. Here, we did that, right? So 1 hour is 3,600 seconds, right? So there's 2 versions of one from this. It's the same thing. Where are we? Okay, so here's the last unit conversion. And then what you're going to do is convert, it's actually, so then you're converting some kiloplex per hour. So it's like some number of I keep on saying, well, you get the kiloplex per hour. And you want to convert to plax per second, right? Lax per second, sorry. So you multiply by 3 versions of 1, and it's related to these 3 different versions of 1. So what I'm going to do is just circle which ones you use. So I want to get rid of kiloplex and change it to plex. So I want to get rid of the kiloplex. So which one do I use of this one? The first one, right? Because that's pretty obvious. I mean, a kiloplex is 1,000 plex, right? That's another way to see it. So that one's kind of obvious. And then you want to get rid of plex in terms of lax, right? So you have plex at the top. So which one do you want to use? This one or that one? The first one, right? That gets rid of plex, right, in terms of lax, right? And then you have hours at the bottom, just like we did in the example in class. So if you want to get rid of hours, which is in the bottom, for seconds, which one do you use, this one or this one? The second one. So you multiply all those things together times the number of kiloplex per hour, right? And that gives you your unit conversion, right? Step by step sort of way, right? Or whatever way you want to do it. It doesn't matter, right? As long as you get the right answer. All right, so does that make sense? Okay, so then the last one, which one is dimensionally consistent? Yeah.
The answer, do you want it with just the numbers or with the unit of measurement? So type it in. Just the number.
Just the number, sorry, just the number.
Okay.
Yeah.
And scientific? I mean,
Just the number. Just the 2 decimal points. Okay. I mean, it doesn't matter. I mean, you can do 2, 1. I mean, as long as you're close to the answer, you get it right. Okay, so let's go to the last one. So the last one is dimensional consistency thing. Once again, this is a multiple choice one. It's the one of the only ways I can ask a question like this. So multiple choice questions are basically gimmies because if you get it wrong on the first attempt, then you know what it is on the second attempt. So I'm going to do a slightly different version of this. So you see another example. If you want to see the solution to the homework one, then I'm going to post it when I post the solution video. So I'm going to do a slightly different equation. It's almost the same, but a little bit different. So let's look at this equation. I think I'm doing this right, because I'm doing it on the fly, actually. I should have thought of this before the review session, but I'm pretty sure this will work out okay. So it's almost like the equations that you see for your homework, but a little bit different. Hold on 1 second. Hold on 1 second. I got to think of the. So the first 2 are fine. I just got to quickly think of the last one. All right, so let me this might not work out, but then I'll do another one. And I'll give you an example of one that doesn't work out, one that does work out. Because I can figure it out what it should be after I do the work for this one. So let's do V2 squared and see how close we get. Then I can adjust it later on. Okay, so. What was it, sir?
5VT squared over A.
Yeah, I'm doing a slightly different one.
Oh.
Okay, so what we want to do is check the dimensions of this thing, correct? So let's do that. So basically you ignore all the numbers, right? Numbers don't have anything to do with this, just like proportions. We're just focusing on the variables, right? So you want to do the dimensions of E times T. That's the left-hand side, by the way. Divided by the dimensions of A. And then on the right-hand side, obviously I ignore the 5, right? And then I'm going to ignore the 2 here. So it's X. Oops. Over A. Yeah, this. All right, so it's X over A. And then I'm ignoring the 5. Doesn't matter if you write a negative or positive either. All we're doing is checking the dimensions of each term, right? So you're not actually subtracting these things. You're just checking each term what the dimensions are. Okay, so dt squared, you can put a minus or plus, doesn't matter. You're just checking the vt squared and seeing what its dimensions are. So, does anyone know what the dimensions of v are?
Over 2.
Uh-huh. And obviously the dimensions of t are what? T. And then what's the dimensions of a? Yes, L over t squared. All right, we'll simplify that in a bit, but let's just go on to the right side. What's the dimensions of x? Oh, what's the dimensions of a again? Yep. And the dimensions of v? Okay, and the dimensions of t is t, but you're squaring it, right? Because it's t squared, correct? T squared. So what is, if you look at the left-hand side, what is L over t, the numerator? L over t times t, what does that give you? L. So you get L. Okay. That's technically enough, but I'll simplify it some more. So what do you do to the first term here on the right-hand side if you want to simplify it fully?
L times t squared over L.
Yeah, you take L and you multiply it by the reciprocal of the denominator, right? That's how you multiply or divide fractions, I should say. Okay, and then this term here is L times t squared over t. So how did the t simplify? Yeah, it's L times t. Okay, so this one is the same thing, right? It's L over t. I'm just simplifying as much as possible, so it's just L t squared over L. Okay. So this is still the same thing. I haven't changed that. So I'm just simplifying step by step. So the L and the L cancels out, right? And you get t squared here, t squared here, and this is minus L times t. So the term on the left is t squared. The first term on the right is t squared. But the third term is L times t. So is this dimensionally consistent? No. They all have to have the same dimensions to be dimensionally consistent. So this is a little bit different than the homework, but you do the same thing for the homework, right? You simplify each expression and see if it's the same thing. So it's a little bit random. Sometimes the first equation that you see is the dimensionally consistent one, then you're done. Sometimes you have to go through a couple of them to get to the dimensionally consistent one, but that's how you do it, right? So the point is you want every single thing to be the same dimensions, right? Simplified to be the same thing. So this one and this one work, but this one doesn't work, right? Because it's not t squared, right? It has to be t squared for it to be dimensionally consistent. So for the homework, you just have to go through them and find the one that works. But they're pretty similar, so if you do the work for one of them, it doesn't work out to be dimensionally consistent. The other ones are pretty similar, so you just have to just look at the term that's different and then see how that simplifies, right? Does that make sense? Okay, so that's it. Does anyone have any other questions or anything else? Okay, so see you guys tomorrow.